sir.
Hi, how are you?
Good yourself?
Good.
So, I'm sorry, I keep having topics on topics.
Oh,
Topics on topics.
that
So, another topic that's kind of cool to look into is that before you even do the question on remainder theorem, sir, what's the logic behind it? How come that when you divide, let's make the, things simpler. So let's say you're dividing an expression by linear.
Okay.
Linear expression.
Right.
And
X minus A. Let us take X minus.
And you're talking about the remainder theorem. And the remainder theorem, that value that you're trying to find would be when that x equals to a.
Right.
So what's the logic behind this?
Correct. So if you're dividing, let's say, a function f of x by x minus a, the remainder is exactly f of a.
Yeah.
Well, the logic is very simple.
Okay.
It is based on the division statement.
Okay.
You kind of remember the division statement. Then f of x is equal to the divisor into quotient plus remainder.
Yeah.
So f of x is equals to divisor, which is in your case x minus a, times any quotient plus the remainder. Now in x minus a, if I put x equals to a minus a is 0.
Yeah.
So the first term becomes 0 and f of a becomes equal to the remainder. Do you see that?
Oh.
That's the logic.
That makes sense.
Yeah.
So we've covered factor and factorable already, and I think it's concrete in my mind. Now I want to talk about remainder theorem, but I don't want to talk about when you divide an expression by a linear function. How about if you're dividing by a quadratic?
Okay.
Can you still follow that remainder theorem rule that you showed me?
Yeah. So that you mean a function is given to you. And if the divisor is a quadratic function, then how do we find remainder without doing long division or something like that?
That's my point.
Right?
Yes.
That's a brilliant question.
Yes.
Well, we can again use the same division statement.
Okay.
Which is function is divisor times quotient
plus remainder. Yes.
To get the answer.
Yeah.
There's a trick involved here.
Okay.
You know, when you are dividing by a quadratic function, what remainder do you expect?
It would have to be the linear form.
Linear form. So take a remainder which is kind of ax plus b.
Right.
Okay. And now let's take an example. Let's say the quadratic function which is divisor for you is, let's say, x plus 1 times x minus 2.
So that's quadratic in factored form.
Yeah, factored form.
Yeah.
So if I write the division statement, I get f of x is x plus 1 times x minus 2 times any quotient plus the remainder. Remainder being ax plus b.
Yeah.
Now if I substitute 1, in x plus 1, if I substitute minus 1, it becomes 0.
Yeah.
So the first term is 0. You are left with minus a plus b equals to f of minus 1.
Yeah,
right?
That makes sense.
And if I substitute 2 for x minus 2, in that case f of 2 will be equals to 2 times a plus b.
That makes sense.
So you get 2 linear equations, right?
Yeah.
And 2 unknowns a and b.
Yeah.
You can always solve for a and b, and that's how you get the remainder.
That makes sense.
Yeah.
That makes so much more sense.
Can you work it out?
Yeah, I can work it out. Yeah. I think you also have an example.
I've got plenty of examples in my playlist.
On this, right? Because after you have those 2 linear equations, you could just use substitution elimination.
Yes, we could.
Right?
And solve.
And you can solve for that. Yeah, that doesn't sound too bad then. Okay, thank you. Clears my doubts.
I'm Anil Kumar. Welcome to my series on polynomials. I hope you're enjoying our outdoor learning process. Here we are back to the classroom. Let us review the basic concepts about remainder theorem and take up a practice test. This time I have 9 multiple choice questions for you. So let me begin with the division statement. So we learned that the function f of x could be written as product of divisor times quotient plus the remainder r. Now what really we mean to say is something like this. So if we have the function and it is divided by the divisor d of x, then the quotient is q of x, and at the end we get remainder r. So divisor times quotient plus the remainder is the function, right? Now let us say that the divisor is a linear divisor x minus a, let us say, right? So let's say d of x is x minus a. In that case, we can write the function as x minus a times q of x plus r, where a belongs to set of real numbers. Now, well, also remember that the divisor d of x is never equal to 0, right? Since you cannot divide by 0. Okay. Now, what is f of a equals to? If I substitute a here, I get a minus a times the quotient plus remainder. Now, a minus a is 0, so basically we say that f of a is equal to the remainder r, right? So this is a very, very interesting and important conclusion. So what are we trying to say here? F of a equals to r means what for us? So this is a relation where we have actually related the dividend so f of a, so that is a part of this, right? Value at x equals to a. F of a is the value of this function at x equals to a. So we have related this dividend with remainder r. So we have related dividend with remainder r. Is that clear? So that actually is called the remainder theorem. That is to say that if f of x is divided by x minus a, then f of a is equal to r, the remainder, right? So then the value of the function at a is remainder. That is what it is. And this is what we call remainder theorem, right? So this is called remainder theorem. So let me write down here. Is that clear? So remainder theorem gives you the remainder directly without even going through the division process. Okay. Now we could generalize it. That is to say, if you divide, let's say if f of x is divided by a term ax plus b, for example, right? In that case, remainder is going to be what? In that case, remainder is going to be f of minus b over a, right? Whatever makes this 0, right? So there are different ways in which we can write this, but most of the time we take this as negative, right? So most of the time we write it like this, that if f of x is divided by ax minus b, then remainder r equals to f of b divided by a. Either way. So I've given you these two ways of writing the same thing. Reason being that in some books we write plus, but in some books we write minus. But the idea is whatever makes this term 0, right, that is the value which we are looking forward to. Is that clear? Now with this small introduction, let's now take up multiple choice questions, right? Question number 1. If f of x is divided by x minus a, then f of a's divisor, dividend, quotient, or remainder. Clearly, f of a is remainder, right? So that is the remainder theorem, right? So that is remainder theorem. In general, we will write like this. When f of x is divided by, let's say, a term ax minus b, then f of b over a is equal to remainder. Right? So that is what we just explained. Now let's take question number 2. The remainder theorem is the relation between remainder and divisor, remainder and dividend, remainder and quotient. So clearly it is between remainder and the function itself, which is referred to as dividend, right? So it is between the function, which is right there, and the remainder, right? These are the two things related with the remainder theorem. Question number 3. Given f of x equals to x cubed plus 3x squared minus 13x minus 15, for what value of x is f of x not equal to 0? So what you need to do is, you need to find the value for f of minus 5, f of minus 3, f of minus 1, and f of 3, right? To really solve for this question, right? So let's do them one by one. So f of minus 5 really means substitute minus 5 in the equation. So within brackets, let me write minus 5 cube plus 3 times within bracket minus 5 square minus 13 times within bracket minus 5, and then we have minus 15 equals 2. We get 0, right? So this answer, we got 0. So this is 0. Now we will substitute minus 3 instead of minus 5, right? So if you have a scientific calculator, this is not a very time-consuming calculation, right? So let's replace all this minus 5 by minus 3. Okay. The last term is a constant, so it is equals to 24. So this is 24, so that means that is the answer. It is not equal to 0. Correct? You can actually continue and check others also. So that really means that for the given equation, x, when we say minus 5 is 0, that means x plus 5 is a factor. And if these are 0, then x plus 1 is a factor and x minus 3 will also be a factor, right? So you could check and then write it. Here is question number 4. The remainder when f of x equals to x cubed minus 4x squared plus 5x minus 1 is divided by 2x minus 3. So we have to find remainder, right? So basically, we have to find the value of this function for f of 3 by 2. You get an idea. So what makes this 0? So that is what you have to figure out. So you should write 2x minus 3 equals to 0. X is equals to 3 by 2. So we are trying to calculate this particular value. Perfect. So that is, we have to write 3 over 2 whole cube minus 4 times 3 over 2 square plus 5 times 3 over 2 minus 1, right? So let's use calculator once again. So within brackets, 3 divided by 2, you could use 1.5 also, whole cube minus 4 times within bracket 3 divided by 2 whole square plus 5 times 3 divided by 2 minus 1 equals 2. So we get this as equal to 7 over 8. So our answer is 7 over 8, which is option D, right? So that is how it could be done. Now at times you may get this question without calculator, right? So let me write down remarks here. At times you may be doing try without calculator, right? Especially for some IB students, they may have this question without calculator. In fact, all these questions without calculator. Question number 5 is a thinking question. When x plus 3 is divided into f of x, the remainder is 4. Determine the remainder when x plus 3 is divided into 2f of x minus 5. So what we are saying here is that when f of x is divided by x plus 3, remainder is 4. It really means that f of minus 3 is equal to 4. That's what it means, right? Now the question here is, what happens when you divide 2 of f of x minus 5, everything, by x plus 3? So basically, it should be using remainder theorem. 2 times f of minus 3 minus 5, correct? Now we know what is f of minus 3. It is 4. So it has to be 2 times 4 minus 5, which is 8 minus 5 equals to 3. And therefore, the answer is C, 3. Perfect? So that's a very good application of remainder theorem. Now, question number 6. If f of x is equals to x plus 3 times q of x plus x minus 1, what is the first multiple of x plus 3 greater than f of x? That means we have to add something to f of x. We have 5 choices. To all, we have added some number. You have to figure out what is the right answer. Correct? So the remainder at present is what? Remainder is x minus 1. And what is the divisor? Divisor is x plus 3. What should I add so that it becomes x plus 3? That could be the question to be answered. Do you see that? So if I add here 4, then I get x plus 3, then the remainder will go one more time. So therefore, the answer is D, which is f of x plus 4. Perfect? That is how you're going to answer this question. Now, question number 7. I'd like you to pause the video, copy this question and answer. Now, this question may involve some calculations. When 10x cubed plus mx squared minus x plus 10 is divided by 5x minus 3, the remainder is 4. Find possible value of m. So basically, we are trying to say that f of 3 over 5 is equal to 4, right? So let us substitute 3 over 5 for x. So 4 is equals to 10 times 3 over 5 cube plus m times 3 over 5 square minus 3 over 5 plus 10, right? So that is what we have. Now, you could actually use calculator and do it. It could be done without calculator also. What I will do at present is I will actually add all these quantities using calculator. But I'll prefer you doing without calculator. Okay. So we have 4 equals 2. So let's do 10 times within bracket 3 divided by 5 whole cube. So I'm missing this out because of m, and I'm doing minus within bracket 3 divided by 5 plus 10 equals 2. So we get 289 over 25. So we get 289 over 25 plus m times, this is 9 over 25. 9 over 25 m. Does it make sense, right? Now we'll take it to the left side. So we have 4 minus 289 over 25 equals to 9 over 25 m. Right. So let's do 4 minus the answer. It is equal to minus 189 over 25 equals to 9 over 25 m. Now we can cross multiply and get the value of m. So it'd be minus 189 over 25 times 25 over 9 equals to m, correct? So it's a negative value. Basically 25 cancels. So what we get here is, when you divide 9 into 189, we get minus 21. So minus 21 is the right option. Perfect. So that is kind of tricky question. It involves a lot of calculations. Doing this without calculator, you may land up into some wrong answers, but be careful. It can easily be done without calculator also, right? Question number 8. Find the sum of m and n such that mx cubed plus nx squared plus 3x minus 4 has a remainder of minus 2 when divided by x minus 1 and remainder of 2 when divided by x minus 2. So basically we are saying that when you divide by x minus 1, basically it is the polynomial function f of 1 is minus 2 and f of 2 is 2, right? That's what is given to us. So let us substitute 1 here in this equation. You get m plus n plus 3 minus 4. And when you substitute 2 in this particular equation, then you get 8m plus 4n, 2 plus 2 times 4 is 3 is 6, minus 4. So you get two equations, right? So this gives you m plus n equals to minus 2 minus 3, which is minus 5, and plus 4, which is minus 1, and that gives you 8m plus 4n equals 2. 6 minus 4 is 2, and 2 minus 2 is 0, right? So that gives you 0. Okay, so 3 minus 4 is minus 1. When you take it on this side, it becomes plus 1. You got that. So we have two equations. We can rewrite these equations as m plus n equals to minus 1, and dividing this by 4, we get 2m plus n equals to 0. We need to find sum of m and n, right? So sum of m and n is clearly minus 1. Do you see that? So option B is the right option. So you need not even solve for m and n for such questions. Is that clear, right? Now the last question here is, when x to the power of 4 plus 2x cubed minus 5x squared plus x plus 3 is divided by quadratic function x squared plus x minus 2, the remainder is of the form ax plus b, right? Since the degree is 2, remainder has to be 1 lower. So it could be linear or constant also. Find the sum of a and b. How are you going to do this? Well, one way is you can actually divide and find the answer. Easy way is, that is tips, right? We have to find what is a plus b, right? We know that the remainder is ax plus b. So to get a plus b, basically x has to be equal to 1, correct? So let's find what f of 1 is. So that is our answer, right? So 1 plus 2 minus 5 plus 1 plus 3. And that gives you 1 plus 2 is 3, 3 plus 3 is 6, plus 1 7, minus 5 is 2. So option E is the right option. Do you get it? So remember, remainder theorem actually makes things very simple. At times we may not even divide but get the answer. These 9 questions actually shows you that. I hope it makes sense. And these multiple choice questions are very important to practice for pre-calculus and many such competitive exams. Thanks for watching and all the best.